Hi, my name is Rizana Atika binti Arzan and my student ID is 2024266702.
Hi, my name is Noorina Shakira binti Hisham.
Assalamualaikum, and my name is Nur Sofia Amira binti Nur Shahriza. My ID is 2024250148.
What is differentiation? So differentiation is a method of finding the derivative of functions. A differentiation is a process in math where we find instantaneous rates of change in function based on one of its variables.
There are a few applications of differentiations, but in this video we will be only discussing two topics, which is the first topic is related rates and the second one is the applications of maximum and minimum problem.
For topic 1, we are going to discuss about related rates. So before we get further ado, I'm going to introduce a bit about related rates. So what is related rates? Related rates is a problem involving two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. Implicit differentiation is often used. Why do we use related rate? Okay, so first of all, it is because it is important, as many times the rate of change of one variable impacts the rate of change of another variable. Secondly, allow us to find equation that involve derivative and that is rates of change of variable.
Problem statement. Air is being pumped into a spherical balloon at a rate of 5 cm3 per minute. Determine the rate at which radius of the balloon is increasing when the diameter of the balloon is 20 cm. For this solution, we use implicit differential method, which is the first step is we need to write the spherical formula for the balloon, which is 4/3 times pi in bracket times radius times t, close the bracket to the power of 3. The second step is take out the information given in the equation, which is the volume is increasing at the rate of 5 cm3 per minute, and we have to differentiate, which is volume equals to 5. And the third step, determine the rate of change of the radius changing, which is d diameter equals to 20 cm, which is r equals to d over 2 equals to 10 cm. For the fourth step, you have to differentiate the formula of a sphere, which is v prime that we have to differentiate equals to 4 times pi times r square times r prime. R prime is what we have to find in this solution. And the fifth step is we have to insert the value that we have obtained in the derivative formula, which is 5 equals to 4 times pi times 10 square times r prime. And lastly, we have to find the r prime, which is the answer equals to 1/8 pi centimeter per minute.
Related rates demonstrate how variations in one quantity influence another. Through the application of formulas and differentiations, we can determine how things evolve over time.
Next, for the second topic is the application of maximum and minimum problems. What are maximum and minimum problems? They are the act of identifying maximum or minimum values is referred as optimization. And numerous problems application in calculus involve functions aimed at determining these action values. And why do we use maximum and minimum problems? To comprehend the significance of maximum and minimum application in calculus. Second, to enhance the understanding of differentiation applications. And lastly, to identify the appropriate formula needed for the stated problem.
A rectangular storage area is to be constructed along the side of a tall building. A security fence is required along the remaining three sides of the area. What is the maximum area that can be enclosed with 800 meters of fencing?
Now, for the solution, the first step is we have to write down the formula for rectangular area, which is length times width, which is length is the y and the width is x. And the second step, we have to write down the equation to find y. And the equation is 2x plus y equals to 800. So to find y, we have to brought 2x to the other side, which is y equals to 800 minus 2x. And the third step is we have to insert the y value that we have found in equation number 1. And it is equals to area equals to x times 800 minus 2x equals to 800x minus 2x squared. Why the square? Because it represents the both side of y. And the fourth step, we have to differentiate the area to find x, which is we have to maximize the area and find the derivative area over dx equals to 0 and differentiate area over dx equals to 800 minus 4x equals to 0, and the answer is x equal to 200. Next, for the fifth step, we have to determine whether the answer we have found is maximum or minimum area. So to determine this, you have to use second derivative, which is if the answer, the value is lower than 0, it is a maximum value, and if the value is bigger than 0, it is a minimum value. So our answer is negative 4, lesser than 0, which is a maximum value. So the maximum area occur when x equals to 200 and y equals to 400, and that area is 200 multiplied by 400, and we got 80,000 meters square equals to 8 HE.
The best or most effective solutions can be found in a variety of fields by using maximum and minimum. That helps handle issues more successfully and will lead to a solid answer.